After finding out the solutions of the characteristic equation, the following step is to obtain the diffraction field, diffraction amplitude of each solution. The solutions can be written as UMM function. This is the initial amplitude. We want to know the diffraction field, diffraction amplitude of each solution. The diffraction amplitude can be obtained by performing the convolution of the initial amplitude with the H function. H function is the impulse response of the diffraction system. So let us perform the convolution. Okay, this integral represents the convolution of initial amplitude and the H function. The process to obtain the final result is complicated, so I just provide you the final result. This is the final result of the diffraction amplitude of each solution. As you can see, it still be a Hermite-Gaussian function, but there are some important properties. Here you see, you still have W of z, R of z, and the phi function here. In the properties of U00 function, we have defined the form of W of z, R of z, and the phi function. And here for Mn order, we find out that the expression for W of z, R of z, and the phi function, they are the same as the U00 function. So the expression for these three in U00 function is the same here. Okay, so this means that the expression of these three functions, they are independent of M and N. The expressions for these three functions are independent of M and N. They are independent of the mode order. The second property is that although these three are the same, there still exists difference. What will be the difference? The only difference is just here, exponential j m plus 1 times phi. This term is the main difference in the diffraction amplitude for each solution. Okay, so for different mode order, they will be accompanied with different exponential function term here. And we have a parameter Cmn shown here. How to find out it? To find out the expression for the Cmn, we can use the power conservation. The power conservation makes that the square of Umn to be 1. By setting this, we will have that the parameter for Umn function will be in this form. According to this expression, we can find out that the parameter for U00 will be C00. It will become square root of 2 over W0 square pi. So these are the properties of the Fresnel diffraction of Hermite-Gaussian functions. They will have the same expression for the W of z, R of z, and the phi function, but have the difference in the exponential term shown here.